Hi everyone, my name is Ttito. I am being director of ROVELLA INMAC, and in this presentation I will share some lessons learned regarding the implementation of BIM and GIS integration in flood control projects in Peru. We will see four topics that I consider to be important for BIM implementation with GIS in a flood control project. Number one, roadmap of implementation. Two, digital solutions. Three, why BIM and GIS for RIBA working stage with BIM and GIS. Roadmap of implementation, holistic vision. Import, Important milestones. It is important to draw up a roadmap thinking about the end of life cycle of an asset so that methods and tools are established and an adequate job is active. In this understanding, we are in charge of a flood control project during the design, procurement, and construction stage. We are the contractors. We are the contractor, and we are under Annex 3 Type F contract. We receive the organizational asset exchange information requirements from the contracting party. Prepared a BIM execution plan we prepared a BIM execution plan in response to an exchange information requirements. Um, a common data environment is development to manage the information. Digital tools are implemented to manage information with BIM and GIS, and a pre-information model is delivered according to the corresponding RIBA Plan of Work 2020 and the asset information model when the transfer is made to the RIBA Stage 7. Well, based on what was commented on the previous slide, we developed a BIM execution plan in which we expressed our roadmap for the project, giving priority to the methodological development of a common data environment during RIBA stage 3, 4, 5, and 6. In the first stage of development of the common data environment, priority is given to spatial coordination through the GIS cloud called GeoCDE, ArcGIS Online, and documentation management for the corresponding studies through a collaborative cloud that we call CDE Autodesk Construction Cloud, and for internal management, a cloud such as SharePoint. Already in the RIBA stage 4, the CDE Autodesk Construction Cloud allows the creation of BIM models in BIM for both linear works and specific works. In the second stage, we develop the common data environment in addition to the first stage allows connecting the field with the office through the visualization of digital plans, model visualizations, model updating, contractual mailings, preparation of advanced forms, workmanships, quality and safety. And the third stage of common data environment development, the CDE prepares for the stage transfers to the RIBA 7. Number two, digital solutions. It's, it is very important to have a support of digital solutions. We really on these digital solutions, GeoBIM is a good option to connect BIM, and GIS data. The mobile application Survey 1, 2, 3, and field maps support us to move information directly linked to disciplines such as land acquisition problems, archaeology, environmental permits during RIVA 3, 4, and 5. The Autodesk mobile applications ACC app help a lot to digitize information during RIVA 4, RIVA 5, and RIVA 6. The importance of adequate BIM information management is to ensure the adequate evolution of information and ensure the transfer of the stage from design to construction, construction to operation and maintenance. With regards to geometric information, alphanumeric information, and documentation, to achieve this in fluid control project, it is necessary to integrate other technologies to the BIM methodology, as they are extensive basins that connect the mountains to the sea outlet. Well, why integrate BIM and GIS? GIS inform and BIM fits GIS. For this BIM-GIS interaction, we noticed that before the information entered a GIS environment, but in a fragment disordered, what that caused rework and that an interaction could not be carried out and contribute to a digital construction. Now, this integration allows us to have geometric, alphanumeric, and documentary information in the same environment as we can see. On this occasion, we support GeoBeam application. In a fluid control project in Peru, we have interaction of various disciplines in the development of Riva Stage 3, 4. We are a lot of information related to GIS. For example, land acquisition issues, archaeology, environmental management, queries for materials and weather resources, basic design studies, and is collaborated and during that the development for construction engineering, the construction of digital assets for BIM models, as we have in the table. It is also necessary to establish GIS and BIM models, exchange formats for work in integration. Below, I will show some work methodologies that we obtained thanks to the integration of BIM and GIS. Revised history spatial coordination and adequate interference identification management is born from the proposals of the outline of the reverse defense to then superimpose them with layers of the other complementary disciplines. Apart from a multi-criteria analysis, we can put the layers with respect to interference, existing structures in projection to the be built or that are in the same place as projections of the riverside defenses. To this, in this example, just spatial information was gathered from the different public institutions of the country to superimpose them and go to their verification in the field. Then, with the support of mobile applications, they went to validate the interferences in the field as well as register new interference. With this information, it is fed into our GIS platform and we connect with Civil 3D in real time. With this, we can connect that validate interferences in the field with being designers and modelers. Here's a flowchart summarizing what was explained above, adding the interactions of the GIS information and the being models built in Civil 3D and Revit. Those are united in a single model. The federated end of design model can be obtained in a BIM and GIS environment thanks to ArcGIS Viewer. The Project Information Model (PIM) for design also contributes to disseminating project information to the resident who would benefit, even before construction takes place, through virtual tours. The BIM models are created with sufficient geometric information to be able to build in Riva 5. A coordinated design is obtained with the least amount of interference and with the available geospatial information rich in alphanumeric information. At the end of Riva 4, we obtain an information model of the project. Each element of the asset is related to the Uniclass codes, whose codes will support collaboration in the next stage. During the construction, information is inherited towards construction teams, graphic information, models, maps, and drawings, alphanumeric information, data-rich BIM and GIS model, and documented information, engineering studies through a common data environment. For the utilization of project management at this stage, we worked Auto's Construction Cloud in its mobile model, connecting the field with the technical office through the ACC app, with which the quality release format, daily reports are worked of advance. Safety and healthy formats in the work. Likewise, the control of the quantities are validated through the BIM model. The BIM models that are created with Civil 3D have the Uniclass 2015 classification system coded to the assets models. Thus, they are also linked to the activity to build these assets. Three commands based on AutoCAD architecture were developed to control the progress of the work through the BIM models of Civil 3D. These three commands facilitate the filtering of the data. The work control model is based on the solids that come out of the corridors of the BIM models. To connect the field with the office in the construction, the ACC app was used, with which we can fill in the data offline directly on the site. It is expected that the digital models have sufficient alphanumeric information for the delivery of the PIM and subsequent delivery of AIM. For the transfers, a model as built is expected from which the final sheets will come out. The final models will be delivered in native formats such as IFC and geodatabase for the PIM. In addition, the GeoGovi data sheet must be delivered. The delivery strategy of the PIM and AIM to finish the work is to deliver all the geographic and alphanumeric information in a free geodatabase station, including the solids are as built BIM models. Tests were made in it can also be opened in free software such as QGIS regarding the documentary information to closures of Autos Construction Cloud and the delivery in the client's cloud are projected. Well, conclusions. The commitment of people and their adaptability to change is key to the success of integration. It is important to work with a work plan that thinks of the entire life cycle of the assets as in the RIBA Plan of Work 2020. It is essential to have a BIM implementation roadmap thinking about the end of life of the assets. For collaboration to be effective, a common data environment must be available. BIM, it is not just making models, but it is a culture of information management that brings many benefits and is a door to digitization. GIS is a very powerful technology that is increasingly needed by the AEC industry. The BIM and GIS integration allows to have the assets within their context or environment, allow to obtain true digital twins in the near future. Well, you can find me at LinkedIn as Roger Tito, and you can send me an email. Thanks very much. See you.